Hello friends, welcome to HP Diamond Academy. In the last lecture, we have completed the discussion on the initial value theorem. Also, we have seen the problems based on the initial value theorem. Okay, so let us start our discussion on the final value theorem. Okay, so let us read the statement. So we have if the Laplace transform of f of t is equal to f of s and f dash t be a piecewise continuous for t greater than 0, and if limit t tends to infinity f of t exists, then this is the statement for the final value theorem, that is limit t tends to infinity f of t is equal to limit s tends to 0 s f s. Okay, so let us write down this. So the what is the final value theorem? So we have if Laplace transform of f of t is equal to f of s and f dash t be a piecewise continuous function. We have already discussed piecewise continuous function for t greater than 0. If um, limit t tends to infinity f of t exists, then limit t tends to infinity f of t is equal to limit s tends to 0 sfs. This is the expression for the final value theorem. Okay, so let us prove this. How we can prove this? Let us prove this. Okay, so we have the Laplace transform of f dash t is equal to sfs minus f0. Okay, using Laplace transform of this we have already discussed now. Laplace transform of derivative. Laplace transform of derivative. Okay, so now let us apply the definition of the Laplace transform. So using definition of Laplace transform, we have Laplace transform of f dash t is 0 to infinity e to the power minus st f dash t dt. This is nothing but sfs minus f of 0. Okay, so we have the final value theorem as let us write down here what we have to prove. To prove limit t tends to infinity f of t is equal to limit s tends to 0 sfs minus f0. ठीक है, तो यहाँ पे लिमिट क्या लेना पड़ेगा, s tends to 0 लेना पड़ेगा. Let us apply both sides. Limit s tends to 0, limit s tends to 0, limit s tends to 0. Okay, so here in this particular expression only e to the power minus st is dependent on s. Rest of the term, that is f dash t, is not dependent on this. Let us put the value of s as 0. So this is nothing but 0 to infinity e to the power minus 0 t f dash t dt is equal to limit s tends to 0 s fs minus f0. Okay, so now e to the power 0 to this is nothing but 1, so we can erase this. Okay, so now we have 0 to infinity f dash t. Okay, so this expression we can write it as limit k tends to infinity, and at infinity we can replace this with k. Okay, now let us further simplify this. So integration of f dash t is nothing but ft, and limit is 0 to k. Okay, and this is limit k tends to infinity, and this is equal to limit s tends to 0 sfs minus f0. Okay, so now this is limit k tends to infinity f of k minus f of 0. This is equal to limit s tends to 0 sfs minus f0. Okay, so we can cancel f0 both sides. So now we are left with limit limit k tends to infinity fk is equal to limit s tends to 0 sfs. Okay, now we have, let us replace k with t. So limit t tends to 0 f of t, t tends to infinity, we can replace with k. Let us replace k with t. Okay, so limit t tends to infinity f of t is equal to limit s tends to 0 sfs. Okay, this is nothing but the final value theorem. Okay, so this we have to prove. Okay, so let us verify this. So this is nothing but limit t tends to infinity f of t is equal to limit s tends to 0 SFS. So this we have proved. Okay, now let us discuss the problems on this based on this. Okay, so what we have to verify? Verify initial value and final value theorem for ft is equal to f of t is equal to 2 e to the power 60. So let us write down initial value theorem and this is final value theorem. Okay, so we have the initial value theorem as limit t tends to 0 f of t is equal to limit s tends to infinity SFS. Okay, let us find this limit s tends to infinity s times of fs is nothing but Laplace transform of 2 e to the power minus 60. Laplace transform of 2 e to the power minus 60. Okay, this is nothing but s 2s times of this is 1 upon s plus 6. Okay, so this is limit s tends to infinity. Limit s tends to infinity. This is nothing but limit s tends to infinity 2s upon s plus 6. Let us divide numerator and denominator by s. So this is limit s tends to infinity 2 upon this is 1 plus 6 upon s. So on taking s tends to infinity, we have 6 upon s tends to 0. So this is nothing but the value is t. Okay, value is 2. So the value of this portion, that is RHS portion, is 2. Now let us find limit t tends to 0 f of t. So this is limit t tends to 0 2 upon e to the power 60. So when t tends to 0, e to the power 60 is nothing but 1. So the value of this will be 2. Okay, so LHS is equal to RHS. Okay, now let us verify the final value theorem. Okay, so for final value theorem, we have limit t tends to infinity, f of t is equal to limit s tends to 0 SFS. So we have limit s tends to 0 s times of fs का value क्या आया था? This is 1 upon s plus 6 है ना? So s tends to 0. So this is nothing but 0. Okay, limit s tends to 0, s की वैल्यू 0 आ जाएगा ना, 0 रखने पे s का वैल्यू 0 रखने पे the value of this SFS will be 0. So we have RHS as 0. So value of this expression is 0. Now let us verify limit t tends to infinity f of t. So limit t tends to infinity f of t is equal to limit t tends to infinity 2 times of 1 upon e to the power 60. So t tends to infinity, the value of this one be infinity. So 1 upon infinity is 0. So LHS is equal to RHS. Hence we have verified the initial value theorem and final value theorem. And let us solve this one. Find f0 and evaluate limit t tends to infinity f of t. Okay. So now considering f of t being continuous at t is equal to 0, then limit t tends to 0 f of t is equal to f of 0. Okay, we have considered f of t is continuous at t is equal to 0, then we have limit t tends to 0 f of t is equal to f0. Let us take this as equation 1. So now we have using final value theorem we have limit t tends to infinity f of t is equal to limit s tends to 0 s tends to 0. Now first we have to find the value of f0 na. So let us use the initial value theorem first. So using initial value theorem, limit t tends to 0 f of t is equal to limit s tends to infinity SFS, s times of fs. The value of fs is s plus 3 upon s plus 2 whole square plus 3 square. Okay, so let us divide numerator and denominator by s square. We have 1 plus 3 upon s upon 1 plus 2 upon s whole square plus 3 square. Okay, sorry, 3 upon s square. So on taking s tends to infinity, so this 3 upon s is 0 and 2 upon s is 0 and 3 square upon s square is 0. So we are left with 1. Okay, so and we have using this one equation 1, we have limit t tends to 0, f of t is f of 0, because we have considered f of t as continuous at t is equal to 0. So f of 0 is nothing but 1. Okay, now let us find the second part of this question. So for this we have to use the final value theorem. Using final value theorem, we have limit t tends to infinity f of t is equal to limit s tends to 0 sfs. So this is nothing but limit s tends to 0 sfs. So this is nothing but s times of this one. So this is s square plus 3s upon s plus 2 whole square plus 3 square. Okay. So let us put the value of s is equal to 0. So this is nothing but 0. This is 0 plus 0 upon 2 square plus 3 square. This is 0. Okay. So limit t tends to infinity f of t is equal to 0. Okay. So we have discussed the final value theorem, theory part of the final value theorem, and the also we have seen the problems. Okay. Thank you.